Hey everybody, let's have another day of circles. Here we go. We are on section 12.3, which is all about inscribed angles. This is going to be a day you want to make sure you have out your highlighters. As I sent you in my email, that's going to be really helpful for this unit, especially for the next couple sections. Have out your highlighters. I'm going to give you tips for how to mark up the diagrams. We're going to be looking at arcs and angles, and there's going to be lots of different chords and lines in the picture. Color coding can help make it easier. This section might seem a little challenging at the beginning, but I am going to give you some tips to try to make it easier for you. So make sure that you're listening for those, and especially trying out the homework. That's where you're going to be able to get your independent practice and really get used to these diagrams. Okay, so let's jump right in. You should see my screen. I hide myself, but you can still hear me. All right. All right, so section 12.3. Oh, there we go. All right. As I said, today is all about what are called inscribed angles. Okay. And towards the end of the section, we're also going to go off on a little bit of a tangent, pun intended. What are called tangent-chord angles. They're very similar to inscribed angles. The way you calculate them is the exact same. It's just visually they look a tiny bit different. The first thing, before we even talk about what an inscribed angle is, let's just recap what a central angle is. So if I draw a circle, here's the center. Anytime you see that thick dot in the middle, you can assume that's the center of the circle. Here's two radii coming off of that center. And let's just say that this arc that I have intercepted between those radii. And by intercepted arc, again, I just mean if you were to trace out the radii and look at the points on the circle where they end, it's that arc in between. That's what we call an intercepted arc. You know, say this was a 50-degree arc. What we've seen is that means that that central angle that's squeezed between the radii also needs to be 50 degrees. And so then the question becomes, what if I was going to be looking at the angle that doesn't start at the middle, but what if I traced these green dots all the way back to a vertex that's on the circle? Hey, remember, a vertex of an angle is just where the angle starts. It's where the rays are stemming from. So for the central angle, the center would be my vertex. And for this angle that's on the circle, that vertex would be that pink dot. So again, this is the vertex of the angle right here. So the question becomes, well, is that still 50 degrees? And the answer is no. If you look at it, that angle got a little bit of a tighter squeeze. So we would expect this angle right here, I'm going to put a star, to be smaller than 50. The question becomes, how much smaller is it actually going to be? And that's what we're going to look at on the first page here. That angle that I have right here with two swoops is what we call an inscribed angle. It's an angle whose vertex is on the circle as opposed to being at the center. So central angle, vertex is at the center. Inscribed angle is an angle whose vertex is on the circle, meaning on the circumference. And the intercepted arc is still the pink one that I have in the picture. It's the arc that's formed where the two rays of the angle intersect the circle. So where I have my green dots, it's the arc between those green dots. You know, intercept means like to catch. If you intercept a football, you caught it. This is where the circle caught the arc. Touchdown! Chords. Okay, I'm done. All right, so here's just a little visual. Here's an inscribed angle. I can tell it's inscribed because the vertex is on the circle. There's my green vertex. If you trace out the chords, this is what I always do. I put my two pointer fingers right where the green dot's at, and then one finger runs along this chord. My other finger runs along this chord, and where they hit the circle, look at the arc that's made between your fingers. This little pink arc is what we call the intercepted arc. And that's going to be really useful for the whole section. Use your pointer fingers as a tool. Put them on the vertex of the circle or the vertex of the angle. Trace them out along the two chords making up the angle, and where your fingers hit the circle, that arc that's made between your fingers is the intercepted arc. So then the big question, how much smaller is that angle as opposed to the central angle? So I'm just going to do this with values to make it easier. I just want to show you how this works. So here's my 2 points I'm going to use. I'm going to call it, I don't know, B and C. And let's just say that this arc right here between B and C, I'm going to make it 100 degrees. This will, you'll see, this will work with any set of numbers, doesn't really matter. I already know that this angle at the middle right here has to be 100 degrees also. So what I'm interested in knowing is, what if I trace this all the way back to this red vertex? Okay. And so here's what I'm going to do. The whole goal is to figure out what that red angle is going to be. I'll call it A. I want to know what angle A is. First thing I'm going to do, I'm just going to draw in green. Let's do this. I'm just going to draw a dashed line that kind of goes right through angle, let's call this in the middle, let's call it O. Okay, so let's just call that angle BOC. And what I'm going to do is I'm just going to split this 100 degrees into 40 and 60. Okay. And you could make them 50 and 50. It really doesn't matter. I just want to show you that it works even if they're not equal. Nothing says that we're bisecting that angle. Okay, so the whole point is to figure out, we're going to need to know what this one is and what this one is before we can figure out what the entire angle A is. Okay, first thing I notice, these two angles right here, this one and this one are supplementary because they lie along a linear pair. So if this one's 60, this one is 120. And if this one's 40, this one has to be 140. Okay, now here's the key. The key is that these two segments right here, this one, and actually this one as well, those are all radii of the circle, which means I know that those three segments are all congruent to each other because all radii are congruent. Well, that means I've got an isosceles triangle here, and I've got an isosceles triangle here. Remember from last semester, if you've got an isosceles triangle, if the legs are congruent, that means the base angles have to be congruent as well. Well, if I look at this isosceles triangle in, let's do yellow, just so you can focus your eyes on one piece at a time. It really helps with these problems not to look at the whole picture at once. This isosceles triangle means these two base angles, I'll put them in blue, this one and this one have to be the same measure. You've already used up 120 degrees in the triangle, and it's got 180 degrees. You got 60 degrees left, which means this one has to be 30 and this one has to be 30. Nice even split. Okay, and you check it, all the angles add up to 180. And I'm going to do the same thing over here. Let's do green for this one. Here's my green triangle over here. Okay, another isosceles triangle. And again, I know these two base angles have to be congruent because the triangle's isosceles. I've already used up 140 degrees. That means I got 40 degrees left before I get to 180. So this one's got to be 20 and this one's got to be 20. So now look at your total angle for angle A. If you add those together, that measure of angle A is actually 50 degrees. So that inscribed angle that we made that went from here to here is 50. And the original arc was 100. So what did we do? We cut it in half. And that's going to work every time. Even if I used like 150 here, or if I used 80 here, it really didn't matter. It's always going to be half the measure of that intercepted arc. So Yoda's reminding you, is this a coincidence? I think not. Okay. So just to summarize here, the inscribed angle was 50 degrees and the intercepted arc was 100 degrees. So the measure of arc BC was exactly 2 times the measure of angle A. Or another way of thinking about that is the measure of angle A is exactly 1/2 the measure of that arc BC. Okay. We already saw from the beginning it got smaller, but we really wanted to know how much smaller. Well, it got half the size. Okay. And that is what we call the inscribed angle theorem. Okay. It's our first major theorem of the day. The measure of an inscribed angle, so remember that means vertex is on the circle, is half the measure of the intercepted arc. So if I trace my fingers out along those chords, there's one endpoint, there's the other endpoint. That intercepted arc in this case is AC. What this theorem says is that this angle, angle B, is half the size of this arc. So if this arc was, 50 degrees, this angle would be 25 degrees. Okay. And if you know the angle, to get the arc, you just double it. Right, so here's where the diagrams start getting a little bit funky. So this is where your highlighters and just trying to keep your eyes focused on one piece at a time is going to be real important. The problem gives you a picture. So just look at the picture for a minute. Look at the different pieces that they give you. got a couple angles, got a couple arcs. Your job is to find arc measures A and B. Technically, I shouldn't have said arc measure. B is an angle measure. Sorry about that. Okay. So our goal is to find arc A, the measure of that arc, and we want to find the measure of angle B. So the first thing I'm going to do is I'm just going to kind of look to see. Let's start with A. Okay. Arc A, it would be helpful if I could trace it back to some type of inscribed angle. I don't see any central angles in the picture because there's no radii coming out of this blue dot at the center. So central angles are not going to help me for this problem. So I'm going to look at arc A. And I notice arc A starts at point P and it ends at point T. So I'm looking at this pink arc, little rainbow. Take your pointer fingers, put them on P and T, and I want you to trace them back along the chords until you hit one point. So take your left hand, trace it back. Take your right pointer finger, trace it all the way back until you hit a point on the circle, and you'll see that they meet up at point Q. So angle Q right there, technically PQT, we should name it with 3 letters. That is the inscribed angle to arc PT. Well, you know that that angle is 60 degrees, which means that that arc measure has to be 2 times as big. So this is going to be 2 times that 60-degree angle, which means that pink arc is 120. So this is just 2 times 60. I'm just doubling that inscribed angle. Now I go to B. Okay. I find angle B. Again, I notice that angle B has a vertex on the circle. So I take my pointer fingers and I'm going to trace it out in red this time. Take my left pointer finger, trace it out to point P. Take my right pointer finger, trace it out to point S. And look at the giant arc that's created in between those 2 letters, P and S. It's the pink one we already have, but now we actually pick up a little bit more as well. What else do we pick up? Let's see. Do it in blue. We also pick up this little bit right here as well. So that whole arc between P and S, and it's a major arc, so I'm going to call it arc PTS. That's the 120 we already had in pink, but now notice we added on another 30 degrees. So between your pointer fingers, you've got a 150-degree major arc. Actually, no, it's not a major arc. Hang on. What do we want? We want PQR. Oh, we're looking at this one. Whole goal of this one is to get, or what am I doing? Hang on a second. I didn't even finish the original problem. Sorry. I'm talking in circles. Sorry. Let's go back up to B. This is what we want. I'm on the wrong problem. Okay. B has a vertex at R. The arc measure created between those red chords was 120 plus 30, so that's 150 total. So arc PS, that's just a minor arc. Arc PS is 150 degrees. So if you trace your fingers back to angle B right here, you got to cut it in half since that's the inscribed angle. So that tells me that angle R, which is just letter B, that's just going to be 1/2 of 150. That's going to be 75 degrees. So I'm just taking the arc that's intercepted and I'm cutting it in half. Okay. Okay, so now I go on to what I was really looking forward to before, which is to find angle PQR. So here's what I'm going to do. I'm just going to color code this now. So let's do darker pink this time. I want angle PQR. PQR is the angle between those dark maroon segments. Okay. Take your fingers, put it at Q. That's the vertex of the angle. There's your inscribed angle. If you trace them out along the dots, one of them is going to end at P and one of them is going to end at R. So you're looking at the entire arc that's created from P all the way over to R, which really is made up of 2 arcs we already found. The pink one we had before was 120. This one was 30, and now they're telling us that R to S is 60. So we can find that entire major arc, PTR, That's going to be 120 plus the 30 right next to it, plus the 60 right next to it. That's going to be 210. Okay, so that big giant black dotted arc that I just made is 210, which means angle PQR has to be half as big, because that's where I trace my fingers back to get the inscribed angle. So that's going to be half of 210, which is going to be 105 degrees. So that's this angle right here. That whole thing is 105. Okay. Again, these take some practice to get used to. Colors help, highlighters help, tracing your fingers outward and just looking at one part of the diagram at a time. If you try to look at everything, your eyes are going to play tricks on you. Look at one piece at a time and focus on one goal at a time. We get a couple corollaries. Remember, that just means extensions to the theorem. A couple extra fun facts based on the inscribed angle theorem. One of those corollaries says that if you have two inscribed angles that intercept the same arc, those angles have to be congruent to each other. So let's just use numbers to make that statement easier. Here's one inscribed angle, angle A. If I trace it outward, that's where it ends. So there's one angle in blue, and the other one I'll do in red. Here's my vertex at B. Trace those chords out. Notice they intercept the exact same arc. Okay, where the red dots and the blue dots meet is the same arc. So, say this guy was 80. Tracing it back to the blue angle, that's got to be 40. But then tracing it back to the red angle, that's also got to be 40. So those angles are congruent to each other. Second one says if you have an angle inscribed in a semicircle, then the angle has to be a right angle. Well, if you have a semicircle, remember that's going to be formed by a diameter because it splits the circle in half. So I know that this red segment that I'm drawing right here is a diameter. If it's half the circle, then that pink arc has 180 degrees. Here's the intercepted arc. It's exactly in between those blue endpoints. Trace it back. This angle C is inscribed to that pink arc. So all I'm doing is I'm cutting 180 in half, which would make sense why that angle has to be 90. So it forces it to be a right angle. So anytime you have a diameter in the problem, the inscribed angle to that diameter is going to be 90. And the last one is really, really useful. There's a couple math Excel problems that you'll find this theorem real helpful. It says the opposite angles of a quadrilateral inscribed means the quadrilateral is being put inside the circle. Those opposite angles will always be supplementary. Okay. Now, again, that's not true for just a quadrilateral in general. It's only true if the quadrilateral is being inscribed inside the circle. Okay. So, for example, let's just say this arc from A to C was 120. Well, the angles or the arcs in a circle have to add up to 360. So that means the remaining major arc here from A to B to C is going to have to be 240, right? Well, let's just look at angle B and angle D. Angle B is inscribed to arc AC. If you trace those chords out, they end at A and C, and I got the green arc in the middle. So I cut 120 in half, and I get 60. And if you do the same thing with the blue arc, angle A or point A and point C, there's your major arc, trace those back. That means angle D is inscribed to arc ABC, the blue one. That one was 240, cut it in half, so you get your inscribed angle, that's going to be 120. And oh my goodness, 120 plus 60 is 180. And if two angles add up to 180, that's the definition of being supplementary. Okay. This is not really a proof. I'm using numbers. Using numbers to prove something is silly, but it helps you see why it works. So just remember, if you have two opposite angles in a quadrilateral, as long as they're inscribed in a circle, those angles have to add up to 180. They're going to be supplementary. So in number 3, we get a couple other diagrams, and we're asked to find in the first one the measure of angle 1, and in the second picture the measure of angle 2. Okay. All right, so let's see what we got. First thing I always do is I try to spot if there are diameters in the picture, because if there's diameters, then I know I can trace the chords back from the diameter to get a 90-degree angle based on corollary 2. So I spy a diameter going right through the center right here, which means that if I trace that back, do do it with your fingers or do it with your pencil, your highlighter. Angle 1 there has to be 90 because that whole semicircle formed from here to here has 180. Okay, so right away I get angle 1 has to be 90, and that's all they wanted in the problem. By the diameters. Second one, we have a 38-degree angle. I notice that's an inscribed angle because the vertex is on the circle. So that one's 38. They tell me that this arc over here, I'll do it in blue, from here to here is 70. And our goal is to figure out what's angle 2. Okay. Well, first thing I'm going to do, I'm just going to notice angle 2 is an inscribed angle. I'm going to put my vertex there. Okay. Let's see what we got. Well, if this is 38, first thing I'm going to do is figure out where does it intersect the circle. So let's take that red vertex and take our fingers and trace it out to the circle. Those two rays intersect the circle here and here. So I spy my intersected arc. I'll do it in pink. That's going to have to be 2 times that inscribed angle. So this is going to be 2 times 38, which is a 76-degree arc. Now, trace your fingers backwards from the red dots and see if you can get it to hit angle 2. There's one chord that ends at angle 2, and our hope would be that this one also ends at angle 2. Trace my finger back, and it's a match. They meet up. Okay, so angle 2 is inscribed to the pink arc, just like the 38-degree angle was inscribed to the pink arc. Remember, if 2 angles are inscribed to the same arc, they have to be congruent to each other. So this one was 76. I cut it in half. That means this also has to be a 38-degree angle. All right. Let's look at one more before we do tangent chord angles. Okay. So first thing, use my tip from before. Look at the diagram, and the first thing you want to be on the lookout for are diameters. Are there diameters drawn? That's a good place to get started. Okay. And the first thing I notice is, hey, there is a diameter right there. So if I trace those back to their inscribed angles, angle 3 has to be 90, and angle 1 also has to be 90. Okay, semicircle is 180, cut it in half, you get 90. Okay, and remember, notice this quadrilateral that we created inside, we know that the opposite angles have to be supplementary. That would make sense why these are both 90. 90 plus 90 is 180. Well, hey, we can do the same trick with angle 2 and angle 4. Okay, so let's see what we got. Angle 4, I notice, is an inscribed angle. I'm just going to use my trick and see if I have the arc measure that's intercepted from that angle. So I trace out one chord with my left pointer finger. I trace out another chord with my right pointer finger. One of those chords ends at this green dot, and one of those chords ends at this green dot. The arc that's created between your pointer fingers is the intercepted arc. So that goes from here all the way over to here. And they gave us that arc measure. It's 60 plus 80. So that entire arc from here to here is 140, which means angle 4 is the inscribed angle to that intercepted arc. It's got to be half as big. So it's half of 140, which is 70. So this entire angle is 70. Okay. We already figured out angle 1 and angle 3 were both 90. Those are the easier 2 of the problem. Okay. To get angle 2, I would just do this the quickest way possible. You have a quadrilateral inscribed in a circle. That means that these opposite angles, angle 4 and angle 2, have to be supplementary. So all I'm going to do is subtract from 180. 180 minus angle 4, 70, tells me that angle 2 has to be 110 degrees. And there's other ways of approaching that too. You could look at the intercepted arc, but you've got some missing pieces there you'd have to find first. It's a little bit trickier to do it that way. Use the fact that the opposite angles are supplementary if the quadrilateral is inscribed in the circle. the last one of the day, last theorem, is what we call the tangent-chord theorem. And the formula works the same way as it does for an inscribed angle. The only difference is instead of the angle being made up of two chords now, it's being made up of one chord and a tangent ray. Remember, tangent just means it touches the circle once. But I want you to look at this. Where is the vertex of that angle? The vertex of that angle is still on the circle. Vertex on the circle, just like it was for an inscribed angle. So what this theorem says is that the measure of an angle formed by a tangent and a chord, so like the blue segment I have in the picture and the red ray, is half the measure of the intercepted arc. And the intercepted arc is still exactly what's squeezed between those two objects. So the intercepted arc here would be arc BC. That arc is 2 times as big as this angle. Okay. So in the problem, angle C is half as big as arc BDC. So if the pink one was, say, 80, then this angle would be 40. If this arc was 120, then this angle would be 60. Still half as big. It's the same consequence that we got from the inscribed angle theorem. So applying it down here, first thing I notice, I have a tangent line to the circle. It hits the circle only one time. So there's my tangent ray. I don't really need the whole line. And there's a chord. So I've got a tangent chord angle. I want to find x and y. Well, in order to get x, I would need to figure out how many degrees are in this arc. And oh no, that's y. That's something else I have to find. So that means, okay, look at the rest of the diagram and see if they gave you any values to work with. They're trying to tell you from here all the way over to here is 230 degrees. Well, what do you know about the measure of a circle? How many degrees are in a full circle? You should say, oh, 360. But the yellow arc and the pink arc make up the whole circle. So this pink arc is 360 full circle minus the yellow arc, 230. That leaves me with 130 degree arc. So y is equal to 130. Just using the fact that the circle has to add up to 360 degrees. But then angle x is a tangent chord angle to that intercepted arc, so it's half as big. So x is just half of 130, which means x has to be 65. I don't want crayon, I want highlighter. There we go. So y is 130, x is 65. The second one, okay, don't let all the lines and segments overwhelm you. Start with one piece at a time. Okay, take a look at the picture. First thing to ask yourself before you start playing around with too much, any diameters drawn in the picture? Because that's going to help you label some 90-degree angles. I see that thick dot in the middle. There's the center, which means this is a diameter, QL. Trace it back. Trace, 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 trace. Trace, 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 trace. Right where J is at, that's an inscribed angle to that diameter. So that's 90. Okay. Next thing. I see a triangle made up of the 2 pink legs and the red hypotenuse. I could probably get y now because I know this is 90. I know this is 35. So the angles in the triangle have to add up to 180. So y is just going to be 180 minus 90 minus 35. So 55. Another one done. Okay, now the last part, and it's probably the trickiest part, is how do you get x? Well, look at what x is made up of. X is an angle that's made up of this chord and this tangent ray, starting at J and going in the direction of K. So I've got a tangent chord angle, which means if I knew what this arc was in blue, all I got to do is cut it in half to get x. Well, how can I get the blue arc? See if you can think about it in the picture for a minute. Is there any inscribed angle you could trace back that would help you get that blue arc? So before I go through it, see if you can take your fingers and trace that blue arc back to an inscribed angle. And you should be able to trace it back to Q. Here's green dot, here's black dot. Trace those back with your fingers, you're going to end at angle Q, which means angle Q is inscribed to arc JL. And angle Q is 35 degrees, which means that arc JL has to be 2 times as big. So this arc here is going to be 70. But then angle X is a tangent chord angle to that arc, which means that has to be half as big as the arc. So X is going to be half as big as 70, which makes X 35. Okay, these problems don't really involve a lot of major algebra. What they involve is a lot more of you analyzing the picture. So it's not the solving part in terms of using the numbers that's the challenging part. The challenging part is going to be trying to figure out what to use in the diagram. And it takes practice. The more of these that you do, the easier they'll get. Okay. All right. That's really it for the content in this section. So what I'm going to do now is I'm going to let you try out some practice problems. There are 6 of them on this page. Here's what I want you to do. I want you to spend the rest of today's lesson trying these out, and then I have the answers posted in the Google Doc. But what I am going to do, I don't usually go through all the you try problems in the video, but I am going to do it for this section in case you want to hear an explanation, because these can be tricky at first. And I think hearing them worked out step by step can be helpful if you're struggling with the diagram. So check the document first. If you get them all correct, no need to keep watching the video. If there's any that you didn't get correct, scroll through to that specific problem that I'm going to go through, and I'll walk you through them. Okay, so try them out, check them, and then if needed, finish this video. All right, so if you're still working, still pause me. If you finished, I'm going to just walk through these. For the first one, you got measure of arc BW, which goes from here to here. So I'm going to look at where the angle intercepts the circle with the arc there at B and W. So all I'm going to do is trace them back. Trace back this chord, trace back this chord. I get an inscribed angle of 62, which means I double it to get that arc measure. So this is going to be 2 times 62, which is going to be 124 degrees. So just double the inscribed angle in order to get the arc measure, or cut it in half if you're going backwards. So number 2 is a case of cutting it in half. I've got the arc measure, that's 98. Trace those back. They both trace back to B, which means this angle B has to be half of the arc that was intercepted. So this would be a 49-degree angle right here. Okay. For number 3, diagram's starting to get a little bit more involved, so just break it down one step at a time. You need to find arc FB, which is right here. And you also need to find our arc ALB, which goes from here to here. All right, so let's see what we have in the problem. And some of this is just a matter of trying to piece it together. And you might not be sure what your starting point should be. So my advice would be, I don't see any diameters in this problem. I'm going to start with one of the numbers they gave me. I see 83. And I notice that B is a vertex for this angle right here. If I trace those chords out with my fingers, I can get that arc FA is 2 times 83, just using my inscribed angle theorem. So that from F to A is 166, but I need arc FB. So it would be helpful if I traced B back. If I trace that back, I get to L. And is there any other letter I can trace back to L? I can trace A back to L. So that 130-degree angle is going to be inscribed to this entire arc BFA. Okay. So how do you get the entire BFA? From here all the way over to here is going to be 2 times 130, which is going to be 260. So that's the entire piece, but wait a second, we already found out this one. This one was 166, which means FB is just going to be 260 minus the 166 we already had. So arc FB is just going to be 94. So this guy right here is 94-degree arc. Highlight that. Okay, so that's one done, but now we also need ALB. So is there a way that we can get arc ALB? Well, we already figured out the big major arc here. Let's see. Let me try, there's so many colors going on in the picture right now. Let me see if I can do this in black to make it easier. From A to F to B, we said was 260. And the green arc that you see labeled there is ALB. That'll complete the entire circle. And the whole circle has 360 degrees. I've already used up 260 for the black arc. So arc ALB is just going to be 360 minus the 260 degree arc that I already had. So that's going to leave me with 100 degrees. Okay, so the green arc is 100. Okay, number 4, diagram not too involved for this one. First thing on my checklist I ask, is there a diameter? And hooray for a diameter. There it is. I know it's a diameter because of that thick dot in the middle, which means if I trace it back, it intercepts a semicircle which has 180. Means that inscribed angle has to be half as big, so that's 90. And they give me an expression for that angle. They're telling me it's x squared minus 54. So all I have to do is take x squared minus 54 and set it equal to 90 and solve. So this one's more of an algebra problem than anything. Once you get to the fact that's 90. X squared equals 144. Now keep in mind for this one, when you square root both sides, you can get 2 answers. So you can get positive 12, and you can also get negative 12. There's nothing wrong with the negative because when I plug it back in right here, negative 12 squared is positive 144. Minus 54 would be positive 90. So I can use the negative answer in this one as well. Only time you throw out the negatives is if when you plug them back in, they produce a negative angle. I didn't produce a negative angle. I produced it at a 90-degree angle. All right, number 5. Find arc ZL. I'm just going to label it Z to L. And find angle D. Well, one thing you'll notice, if you have this little bow tie shape, that's pretty popular to show you that there's 2 inscribed angles that are both intercepting that arc. So let's see if we can find them. I'm going to put red dots at Z and L, and I'm going to try and trace them back to 2 different angles. So first time, I'm going to trace this one back to D. Is there a way I can trace L back to D? Yes, there is. Let's do the other one in blue. Is there a way I can get from Z to E? Yes, there is. Is there a way I can get from L to E? Yes, there is. So you'll see I've got the red angle and the blue angle both intercepting that yellow arc ZL. By the corollary we had earlier, that means that these 2 angles have to have the same measure. So all you got to do here is take the expressions and set them equal. I know 3x plus 30 has to equal 8x minus 15. So moving things over, I get 5x equals 45. And dividing by 5, that tells me x has to be 9. Okay. Problem's not done, though. They didn't ask you for that. They asked you what's the arc measure ZL and what's angle D. You got to plug it back in. You don't have an expression for the arc, so you're first going to have to plug back in for angle D. So I'm just going to do 3 times the value I just found, 9 plus 30. 27 plus 30 is 57. So this is a 57-degree angle. And, they didn't ask for it, but that means this one's also 57. So then, ask yourself, how do you go from an inscribed angle back to an arc? Do you divide it by 2 or do you multiply it by 2? And you should say, oh, well, this is a tiny, tiny angle. The arc's getting a lot bigger. I'm going to multiply by 2. So this is just going to be 2 times 57, which would be 114. Okay, so to summarize, angle D was 57, and measure of arc ZL is 114. Those are the 2 pieces they asked for. All right, and now the big one, the one where you probably have to use the most color, and just kind of think about the diagram. You're not going to get everything at one time. You're going to have to kind of break it down and look at it for a little bit. These problems take some patience. So one thing I notice, sadly, there's no diameters in the problem, but they do give me a center. This blue dot that I'm putting there is the center. And so to get me started, the first thing that I spy in this picture is a central angle. Here's a radius, and they squeezed a 100-degree angle between that, which means that this red arc It's not going to be 200 because this is not inscribed. This is a central angle. It's always equal to the arc measure. So just to get me started, I get that arc BC is 100 degrees. That's the one I can knock out right away. Well, what else do they want? They want angle BEC, which let's see if we can trace that back. That's this angle right here. If I trace those chords out, I trace it out to B, and I trace it out to C. Look at the arc between your pointer fingers. That's the 100-degree arc we already found. So how do you go from the arc back to that inscribed angle whose vertex is at E? You cut it in half. So this is going to be 50. All right, so we got 2 knocked out. That's good. Let's see what else we can find. I want, nothing says we have to do these in order, so let's just kind of piece it together. We want arc C, B, E. So I'm just going to highlight that and see if we have enough information to find that. Let's do that in black. From C to B all the way over to E is that big giant black arc right here. If I try to trace that back to an inscribed angle, here's one endpoint, here's the other endpoint of that arc. It traces back to D. And hey, look at that, they gave me D. That's 150, which means the arc has to be 2 times as big. So the big black arc is 300 degrees from E to B to the whole thing. So this is going to be 300. I just took 150 and doubled it. All right, so can I get arc BE now? I can, because I know that the whole black arc is 300, and I know that from B to C is 100. So to get arc just BE, I just take the 300-degree black arc, and I subtract off the 100-degree red arc. And that'll leave me with, let's use a new color. Let's use green. We already used green. Let's use a darker pink. So this pink arc from B to E is going to be 200 degrees. Okay, so we got 4 of them knocked out. All right. Let's see what else we got. Angle ECD. Okay, so let's label that with a new color. We need some more colors. Let's do teal. So this is too bright, too bright. Let's do orange will probably be better. Okay, there's my orange dot. That's angle ECD. Trace it out. That hits E and that hits D. So this little arc that's intercepted is 20 degrees, which means angle ECD has to be half of that. That's got to be 10 degrees. So I get a 10-degree angle for ECD. Now I need CED. So now that means the vertex needs to be E since it's listed in the middle. What do we got? Let's see. Well, if we need CED, let's trace out in pink again. Here's E. Tracing it out, it lands at C, and tracing it out, it lands at D. So this arc right here, ooh, we don't have that arc. Is there a way we can find that arc? Let's see, do we have all the other arcs in the picture to start with? We got 100 for this one. We figured out this one was 200. We know this one is 20, and hey, look at that, this is the only one left. What do all of the arc measures in a circle have to add up to? 360. So arc CD is going to be 360 minus what we already found. The big black one was 300. We added on an extra 20 right here, so that's minus 320. And so that leaves this arc being 40 degrees. So we actually just found arc CD, that's 40. And then angle CED is the inscribed angle to that arc. If you trace those back, you end at E, which is on the circle. That means that angle has to be half as big. So that's going to be half of 40, which is 20. So again, these take some time. The more you practice them, the easier they'll get. I think of them kind of, they're like puzzles. All right, so that'll do it. So your Math Excel is up. You can work on that. And then I'll be on the office hour. I'm sure there'll be some questions on this. Definitely, I encourage you to log in and ask about it. These take some time to get used to, but they are very rewarding once you solve them.